Good morning and welcome. My name is Emilia Pisani and I'm Communications Officer at Johanna Berry Science Park in Gothenburg, also working with the Celsius Initiative, and I have the honor of being your host today. Considering the current environmental and geopolitical crisis, it is crucial that we maximize the use of energy being produced in a sustainable way. Moreover, when looking at the future of energy systems, the integration of thermal and electricity grids is inevitable. With this in mind, the D2Grids projects and the Celsius Initiative have come together to bring to you this webinar on renewable energy and fifth generation DHC. So without further ado, I have the pleasure of introducing my co-host, Mathilde Henry, who is Consultant Project Manager in Energy Transition at Greenflex.
Thank you, Emilia. Yes, so welcome everyone to this webinar. I'm indeed Mathilde Henry. I'm a Project Manager in Energy Transition at Greenflex, which is a French consulting firm specialized in energy and environmental transition, and member of the D2Grids consortium that I will present in a few minutes. Thank you.
Great, thank you. So starting with these, you are hosting projects. I'll give a quick introduction to the Celsius Initiative to those of you who don't know us. The Celsius Initiative is a demand-driven collaboration hub. We've been around for about 10 years now. It started off as a 7th framework program project. So it's like the grandparents of the Horizon Europe now. And somehow we've managed to live on and continue making an impact and working on our purpose, which is to accelerate the energy transition through the deployment of smart and sustainable thermal solutions in cities. How do we do this? Our philosophy is not to reinvent the wheel. We do continuous knowledge sharing through webinars like this one, workshops, and the Celsius Toolbox, which you will find on our website, where you find project results and key information regarding heating and cooling networks. We provide hands-on support for cities through tailor-made discussion groups. I'll go in a little bit more in detail through that. Also, it's great to share knowledge. It's great to provide support, but we also need the right policy framework. And so by building on our network, we try to also understand and influence European policy. Last but not least, we support innovation, replication, and scaling of demonstrators. There are plenty of fantastic solutions, some of which we'll learn more about today, being implemented. So how can we replicate and scale them at a European level? Next slide. So about these discussion groups, we like to be a sounding board for local actors, looking at the big picture to identify and address the challenging pieces. It has been built on a co-creation process and peer-to-peer learning exchange and inspiration, because oftentimes we see experts and projects coming in with a solution, but not always asking what the challenge is, what the problem is. And so when you ask what the challenge, what the problem is, then we can connect to solutions that are existing in our network and promote the exchange between similar actors with similar challenges. We try to include a systemic approach, so meaning not only looking at the technical problem, but also looking at stakeholder interaction, policy, financing, everything that goes around in implementing these sustainable solutions that will guarantee us a better future. We also promote proper planification of these solutions, because there are so many lessons learned from other projects, from other cases, that can help a successful implementation of sustainable thermal energy networks, avoiding costly mistakes and avoiding, just mistakes that have already been made. Thank you. So I talk about these discussion groups, and we bring together a network. So now if you could please present the next slide. As you can see, this network is built of local official representatives of local energy companies, but as well as research institutions, European institutions, national institutions, working with cities, with heating, cooling, and sustainable energy networks. Thank you very much. Mathilde, what can you tell us about the D2Grids, which is one of our collaborating institutions or projects from Celsius?
Yes, thank you, Emilia. So D2Grids is a European project that is funded by Interreg, so one of the European Commission program to fund this kind of innovative initiative. It has been started in 2018 and it will end at the end of next year. The objective of D2Grids is to increase the share of renewable energy in the Northwest European countries' heating and cooling sector. Since it's a sector that is not using enough renewables, in our opinion, for now, only 19% is sourced from renewables. And to do so, we wish to accelerate the rollout of 5th generation district heating and cooling, which we'll have a presentation in a few minutes by Herman, so I'm not saying anything more about it now. How do we do that? We started by defining a standardized technological model for what is this 5th generation of district heating and cooling. We wish to increase the adaptability and the replication of these systems by a really standardized model that can be used by as many grid operators, grid owners as possible in future projects. So that's more the technical approach. We also have a commercialization approach, clarifying the business model of these grids and promoting this solution towards the industry. We have also an educational role as we wish to disseminate this technological model, these business models to as many grid operators, grid owners, technology providers as possible. And we develop some training modules to do so, some courses to develop some skilled workforce that can propose and improve these models and develop future projects. And to finalize this global approach, we are demonstrating and testing 5GHC on 5 pilot sites in different countries. We have a pilot site in Paris, which is the Paris-Saclay district heating and cooling. We have one in Glasgow and one in Plymouth in the UK. We have one in Bochum in Germany and one in Bernssum in the Netherlands. So all these 5 pilot sites will test this technology in different structure, different local context, different energy sources, different type of consumers. And they will be helped by all the other partners that are technical experts or financial experts and can help them and give them advices on the technological choices, the business model choices that they can promote in their pilot test.
Great, very exciting, a lot to look forward to, a lot to cram into this 1.5 hour we have in front of us. So what can you expect today? We're going to start to talk about what is this 5th generation district heating cooling that everybody seems to be talking about and that we will be focusing on today. And how can solar in particular, and so particularly sort of photovoltaics be used? So once we have that general idea, setting the screen, we'll look more in detail about the pilot sites in the D2Grids projects who are really demonstrating successfully how this can be done. And last but not least, we will hear about a case study of DHC Grid and solar in Sweden, where Frampton AB will be installing solar panels in other buildings. But I will just leave you with that one and hope you stay with us until the end because it is very interesting presentations for the next 1.5 hours, or 1 hour and 15 minutes now, looking forward to. So without further ado, Herman, you have a long experience with heating, cooling as a director of innovation in Mindwater. What can you tell us about what are 5th generation's district heating and cooling networks?
Thank you so much, Emilia. Good morning, and thanks for giving me the opportunity. Actually, we have a small company in the city of Heerlen in the south of Netherlands, and we started finding underground water from former coal mines, which is heated up by geothermal heat. And we started to build a grid on that in the city for the heating and cooling of buildings. And when we look into this development of district heating grids, and I have here the picture from Aalborg, I think well known for those who are in this business, then we see a build-up from like 1880 already more than 100 years up to 2050. And we see that those grids get lower temperatures, but also, and they get multiple sources of green energy to feed the heating demand. Actually, in the fourth generation, we also see some small line running out of the scheme for district cooling. But one remarkable thing in all these schemes is that it's all based on central plants. And this concept of a central plant feeding a city from one point has a few disadvantages. One of those is that we are dependent on the weakest point in the city. And if the city changes, so if buildings get insulated, it's quite difficult to adjust this district heating system to those changes. We need to be there 24/7. So if somebody needs heat or domestic hot water, it must be at his front door. And actually, there is cooling in the fourth generation, but it's not integrated into the heating and the cooling support. So please, next slide. And if we look into these kind of grids, and we see different systems. The centralized grid is on the left. And if we look into IT sector, we see that these centralized grids have been developing in decentralized grids and in a kind of a cloud system. Actually, we also see this happening on the power grid. So if people start to have the solar panels in their neighborhood, and we get some kind of a decentralized grid for electrical power. And somehow the most right scheme is a full cloud grid, which is not actually there, not an IT and not an electrical. And what we want to do on the thermal grid, and that's what we were developing in the city of Heerlen, is also to move from a centralized grid to the right to a cloud system. Next sheet, please. That brought us to a twin pipe thermal system. And this twin pipe means that you have one warm pipe and one cold pipe. And if there are dwellings connected to the system, they will take heat from the warm pipe but also return cold to the cold pipe. Because this idea is that we have decentralized system mostly based on heat pumps, which you can use from the front side and the back side. So if the front side is giving heat to the dwelling, then the back side of this heat pump will return us cold, and we can feed this cold pipe with this cold. If your neighbor has a different situation that he needs cooling, and you can take that one from the cold pipe, and then you will return heat to the hot pipe. So you get a system which is feeding those both lines. It's not like we knew supply and a return pipe. It's actually two supply pipes, one supplying cold and one supplying heat. In this scheme, you also can add renewable sources, and it can be local sources. You can add waste heat from industry. And finally, if you look over the city, you will find that there could be a net shortage of cold or shortage of heat. And you try to fill this in with a storage which is in the system. Finally, if you can't get that heat or cold demand from your storage, then you have to find external heating and cooling sources and use external energy. So this is a bit more difficult scheme. I will not go into detail, but it's kind of showing what's happening in those twin pipes. If you look into it, and more technical people in the audience might understand the idea of this picture. It's actually explaining a bit more what I told in the former sheet. And even if you start the system and not with, like we do with mine water, but take 15 degrees Celsius on both pipes, you can see that this temperature will develop over the city and finally you get up with a higher temperature. Just an example showing here could be like 33 degrees Celsius and 11 degree on the cold pipe, which also means that the further you get and the warmer or colder those pipes get, the better the performance of your heat pumps can be. Even actually, if you have new buildings on this, at some point you could just bypass the heat pump and directly feed like an underfloor heating with this one pipe temperature. Next slide, please. How did we come to this system? Actually, we had a very simple assumptions in the beginning. We said it's kind of weird that we have one building, and if we do them all electrical with heat pumps, which is blowing away heat from the roof, and that this neighbor is blowing away cold from the roof. So in the D2Grids project, we started to think, in practical, we said, that's not a good idea, let's connect them. But then we started to think, why are we doing this? And we came up with 5 principles. And what I just told actually comes back in the first principle. So try to close that energy loop. If somebody needs heat and somebody else needs cold, connect them to each other and start to exchange these amounts of energies, which means actually that you all over the city could have a saving of in the order of 30%. The second idea that we had is it's also bad if you need to raise a building with 20 degrees Celsius above the outside temperature, that you start using flames and very high graded sources, like a 1000 degrees Celsius flame, just to bring up the building 20 degrees Celsius. You better use this like in industries or other goals where you need these high temperatures, and they will give you a waste flow, and you still can use that waste flow for the buildings. So you use the amount of energy that you bring into the city 2 times, first for the high graded processes, and then after that for the low graded processes. The third principle is build decentralized systems and demand driven. As I showed in the first picture, if we have to bring energy 24/7 a day or a week, we know like heating systems here in the Netherlands, they will have losses of about 70% at summertime if they only bring your domestic heating for domestic hot water. If you have a demand-driven system, you can do that much more efficient and also adjust to local changes. So if you insulate your building, then you can adjust your system to this new situation. The fourth one, and I will have a picture of that later, is try to integrate energy flows, because buildings, we are talking about buildings are only like 10 or 15% of the heat demand in the city. So there are many other heat flows, and if we integrate them, you can find great benefits from that. And the last, use local sources. So often we are talking about the Sahara or other ideas, big windmills on the sea, and I think it's very fine, and we have to do those things. But if it's in your backyard, why don't you start using the energy in your backyard? And if it's not enough, then you always can go further down. So from these principles, and then you have to fix some system boundary to access those data. We were working on defining KPIs. So if you can find a KPI which is giving you an idea how good you are doing on this principle, and maybe you want to put a wave factor behind it, then you can give it a label. And why do you want a label? Well, at some point you can check the system on many criteria and many performances. But if we want financing, and then we need trust in those systems, and this label could give trust to big investors that they get a good working system. But actually we said it's not about putting labels and telling this city is better than the other one. Actually, what we try to find from this is guidelines, advices, which will show us how we can improve our system, because we are talking about district heating cooling systems which will last for a long time and will have developments over 30 to 50 years. So what will be my next step, and can I see from this kind of assessment what will be good steps to get a better performance out of my district heating? Okay. Actually, then what we get is a system, what we call a multiple source and multiple storage system. So we look on the city level, and there we might have a big, like an aquifer, or what we have, the reservoir of mine water. You might feed that reservoir with very low graded sources. And from that point, you bring it into the neighborhood where you raise the temperature, at least up to space heating demand. And you also want to build a storage there and feed them with other sources like industry waste or solar thermal waste or from conversion energy. Finally, you get into the building at the right and into a dwelling, and there we use small booster heat pumps, which will give the last raise in temperature for domestic hot water. And even there we have the small vessels like 150 liters, which can be fed by local solar energy. Okay, the next. And actually what we are doing is we are reducing the amount of energy that you need for a building. And this example is for one dwelling, and the actual energy demand in such a dwelling in the Netherlands is about 20,000 kilowatt hours. And we do want savings in those dwellings. So we want to improve insulation, and we want to take energy saving measures, which could take out like 30 or 40% of the energy demand. The remaining amount is fed by the exchange with cooling, but also with the low temperature waste heat that we can bring into those systems. So actually more or less 50% of that demand must be fed with auxiliary energy. And for that we use the heat pumps, which are quite effective because they are not running on air, they are running on warm water, bringing it back to a very small amount of electrical energy. And I don't have the figures in the picture, but if we talk about one dwelling in the Netherlands, the left side would be 20,000 kilowatt hours, and you bring it back to 2,000 kilowatt hours, which could be done with like 8 or 10 solar panels on your roof. Okay, the next. So this
Just
idea.
want a quick reminder to start wrapping up.
Yes, I'm nearly done, Emilia. Thank you. This is what we're doing in the city of Heerlen, and we have this D2Grid projects to see if on other places in Europe we can do the same thing, and actually how we can see that, as Mathilde said in the beginning, that we want to get from 90% to 50% of energy saving, that this kind of technology will give us this kind of saving for buildings in the cities. Next one, please. So this is my final sheet, and this is also showing this picture. It's a Dutch amount, the pie at the Dutch amount, where it shows that only like 10% of the energy is going to dwellings. And now if we are looking into future, we can think what would be the next steps, and we found out that now we spend a lot of time and a lot of investment into energy systems which are affordable and also I can say acceptable. And we try put a lot of effort into insulating of buildings, but it costs us a lot of money and a lot of time, and we find resistance if we go deep into those buildings. So from this point of view, from this technology, we should have another order in how we approach this energy systems. And the first thing should be try to get your supply temperatures down, because the lower supply temperatures you need for the building, the better. The second one is to reduce the amount of power, and specifically in the peaks. So can we reduce peaks powers? And then the third one would be save energy. And then finally, if we want to get there in 2050, I think we need one thing, and that's going faster, faster, and faster. So we should develop systems which are plug and play, which will be foolproof and will be smart with a lot of controls and a lot of IT in there. Thank you so much.
Thank you. Yeah, for wrapping it up so quickly. I'd like to invite all our listeners to use the Q&A or the chat section in case you have any questions for Herman. But in the meanwhile, I have one question for you. You talk about this fifth generation, which is almost ideal anywhere you'd go. Is it relevant for existing networks, or is it only for new production?
Actually, yeah, that's a question that we get a lot. For in the Netherlands, like we have 6% of district heating now. So there is a lot of green fields where we can apply and build islands of this fifth generation systems. Just take a neighborhood and you can start on a very small scale. But actually, if we look at the existing grids, then we see that they have to expand too. So they have, at the 6%, what we have, they have to expand up to 30-40% in the coming 30 years. And then the fifth generation could also be a very good strategy to connect like green leaves in an existing grid, use that old grid as a backup for peak powers. And in time, if those districts develop further into the future and get greener, then you will use this backbone less and less. And at some point, maybe in 30-40 years, you even can skip the old system and step over to the new fifth generation system. And actually, that I didn't say, but the 5 principles, they are ideals. So you will never get 100% of those principles. But you try to get as close as you can to that ideal. It's like a dot on the horizon where you develop your grid into the future and make it better and better.
Great. I have a question from Igor here, and he's wondering, what is the feasibility of using biogas from AD process from water waste treatment plants as means for provision of heat into the network during peak times?
That's a very good idea, and it's certainly for the short time, but in a bit longer time, we would like to use that high-graded gas. Maybe you want to melt steel, or you have other processes where you can use that high-graded source first, and then take the waste heat out of those industries and reuse it for the buildings.
Great, and a colleague here from University Park, who's wondering, is very much support of faster approach, but how do we address the lower temperature approach to existing buildings with gas boilers without significantly improving thermal efficiency? Could you give some more thoughts on this specific example and on the faster plug and play or foolproof approach?
Yeah, we have some strategies, but it takes a lot of time to explain, but I try to do it in a short way. So we can take measures in buildings. We can, even if we have the double glazing, we can take out the glazing and replace it by high efficiency glazing. We often can improve the ventilation system. So put some heat in the support air, and even in summer, cool down the support air. But try to find measures will not disturb these buildings too much, specifically for dwellings. The office buildings, it's often a bit easier, but for dwellings, if you have to disturb them, if you have to take the people out of it and do a big renovation process, then you will get a lot of resistance. So try to do these measures, and that could be roof insulation, it could be on the floor insulation or cavity insulation. And as I said, the venting system to improve that one, which will give you like 30-40%. Then your supply temperature will get down back to like 60 degrees Celsius, and we can do everything with the heat pump. If they go further, in future, maybe in 10 or 15 years, take more measures on insulation, then it means that you get the amount of energy that you bring them, that you save on that, and then we can connect the neighbors on the same system. So the better they insulate in time, the more we can connect on the same pipe.
Thank you. I see all these questions popping up, which is amazing. Unfortunately, we have to move forward, but I will keep them and hopefully we'll have time at the end of this presentation. Otherwise, we can always follow up.
Yeah, maybe if people have urgent questions, they could send it in the mail or go to the website of D2Grids, and then we will answer them outside of this webinar.
Absolutely. Otherwise, you can also type the answer in the chat. But without, thank you for that. And without further ado, once again, Mathilde, can you let us know? So now we know how these fifth generation district heating and cooling networks, what they are, how they work, what role does solar energy have to play in these fantastic, almost future-proof networks?
Yeah, that's a really good question that in D2Grids, we decided to go a bit further. We had an extension of the project to study in particular the coupling of the electric grid and the heating and cooling grid. And I will explain you why we thought it was like a really urgent matter to address. So as Herman presented, the principle 2 is focusing on using low-grade sources that are coupled with heat pumps to bring the temperature to their required level as close as possible at the end user. But these heat pumps consume electricity, of course, and if everyone needs heating, for instance, at the same time, maybe at the end of the day, when everyone is also consuming electricity for lighting or other uses, it might also have an impact on the electric grid, and it might create peak loads on the electric grid. And we know that most of the time peak loads are filled with fossil fuels. So there's an urgent matter to have a more holistic approach, an integrated approach of the energy flows, not just considering the heating grid and the peak loads on the heating grid, but also explaining and studying how the consumption of heat pumps will have an impact on the power grid. So to compensate this aspect, the principle 4 that Herman explained quite well is to get this approach of the energy flows in an integrated and holistic view. Herman mentioned the fact that there are different solutions to fulfill that goal. We can use some thermal storage to reduce the peak loads. So we have thermal storage that will store thermal energy that will be used during the peak loads so that we don't ask too much from the heat pumps during the peak loads on the electric grid. So that's one solution. Second solution is to have advanced demand side management to shift the peak loads to capitalize on the thermal mass of the buildings. Thinking back, maybe if we heat up the buildings a bit before the peak loads that we assume will be happening, then if the building is quite efficient, it will keep warm and we won't need to heat it during the peak loads. So these two parts are more on the thermal aspects, and we're not studying it today, but you will find a lot of information on the D2Grids website. You can go on 5gdhc.eu, where you will have some best practices that are used by the pilot site on these subjects. And today we will focus on the third option, which is to produce and store its own electricity so that we don't need to create additional peak loads on the electric grid. Next slide, please. So the goal of D2Grids on this particular matter is to encourage grid owners, grid operators, municipalities to have an integrated approach of the energy consumption of the power grid and the thermal grid in order to reduce the greenhouse gas emissions and also to reduce the energy costs. So the first goal is to bring the best practices for production, for distribution, for storage, and the management of local renewable electricity inside the best practices that we have developed in the 5GDHC grids. And yeah, that's the first goal. It's not about inventing new technology solutions. It's just bringing all the best technology, best practices all together, bringing the best practices from electricity and from thermal grids. The second goal of studying that aspect is to create a local energy community with low carbon emissions. So as I said, if you produce your own electricity, you will you will participate to avoiding peak loads on the grid and therefore the use of fossil fuels. And you will produce your own electricity through, for instance, PV systems, which are renewable energy. So you will decrease the carbon intensity of the use of your grid, both the thermal and the electric grid. And it also enables to make consumers become prosumers. As Herman already said, the goal of 5G is already to encourage consumers to become prosumers as they exchange heat and cold among them and are not just passive consumers. Bringing the electricity system is also a solution to do so, because the PV panels could be installed in on each building rooftop. And the consumers could be the producers of this electricity that could be used either for their own consumption, but also for the grids and the heat pumps consumption. So there are a lot of solutions that could be used thanks to these consumers that will become more active in the grid strategy. And the third aspect is, well, as you know, the energy costs are rising drastically, including the electric costs. So the 5GHG is already has already the goal of reducing the consumption of gas, but it needs to reduce also the consumption of electricity from the grid as the costs are rising. So the fact that we can invest in solar PV to provide electricity for the heat pumps, provide a long-term visibility and protect the territory community from the cost evolution that we have seen in the past month, and that will keep rising in the next to come. So on a technical point of view, there are different solutions that already exist and that can be used inside the 5GHG grids to produce the local renewable electricity. So there are, of course, the solar energy solutions, bringing the concept of power to heat, so self-produced renewable electricity to provide electricity for the heat pumps that will provide heat. So there is electricity installations in the 5G grid for the heat pumps. It can also provide electricity to other consumers of the district, the housing, the stores, electric mobility, other uses that could be also provided by this electricity that could be shared between the uses of the grid and of the rest of the uses of the district. It can be either only photovoltaic panels, but it can also be some thermal or PVT hybrid solar panels that could also produce domestic hot water that could be complementary to the heating that comes from the grid. So there are different solutions on the solar production part. And storage facilities are also really interesting. As you know, PV panels produce only when there is solar, obviously. So if you want to use it when there are a lot of peak loads that are to be expected, so mainly when there are less sun, you need storage to store the electricity that will be produced during the day and use it at the best time. And last but not least, some smart monitoring and control could be also used to balance the demand and the supply and to allow for different operational models. And so, as I said, you can provide the green electricity to the thermal grid or to other consumers. You can sell the surplus electricity to the grid operators, to the national grid operators, or you can store the electricity to balance the fluctuations. So there are different things that could be managed through smart monitoring to best use the electricity that is produced thanks to the solar solutions. So as I said, it's not really a technological challenge, as we already have the existing technologies on the market that might need to decrease their cost, especially for storage. But it's mainly a governance challenge, governance innovation. There are different aspects that can be studied and that will be studied inside the D2Grids project. There is how to finance the installation. There are different solutions that exist. The energy could be produced, owned, and stored by the grid owner, by the grid manager, but it could also be sold by a client of the DHC, as I said, and we will see an example from Paris-Saclay right after, or it could be a third-party financing or a bit of all of these options. So there are a lot of solutions that could be studied in the financing and owning aspect. Also, there's the contracting and governance aspect that is really interesting to be studied. How to manage the distribution of the energy that is produced among the users for shared benefits. If it's not only used for the DHC grid, as I said, could be used for the other buildings, other consumers, for other uses like electric mobility, or it could be used for the electric grid. And finally, the revenues and pricing. How can you make some economies thanks to producing your own electricity? How can you select or define the price of the electricity? For instance, if it's a consumer of the grid that is producing the electricity, and can they have an exchange of benefits if one consumer produces the electricity, sell it to the grid, and he pays for the heating in exchange? Or also we were thinking maybe there could be a social electricity price, for instance, reducing the price for social housing families, getting higher for richer consumers. This kind of things that are interesting to be studied. And I will not give you much example for now because we'll have a nice roundtable right after with a lot of examples on the financing and governance aspect of the grids. Thank you.
So now we know about the 5th generation district heating and cooling networks, how to integrate solar. What does it look like in real life? And I would like to invite our roundtable panelists to turn on their videos and in a couple of minutes, a quick overview of what does your pilot site look like? What have been the lessons learned and success stories?
Thank you, Emilia. Maybe we can start with Paris-Saclay, just presenting quickly their pilot site before we go indeed into the PV aspects and solar aspects. So we have Lucas Lazzarini from Sequence, which is actually one of the consumer of the grid of Paris-Saclay. And he has a video that was prepared by the Paris-Saclay grid operators, grid owner, which is EPAPS, that will explain how the grid works before we go into more details on the solar aspect.
The Paris-Saclay District Heating and Cooling Network supplies the Paris-Saclay urban campus by using local energy sources. It is the first 5th-generation district heating and cooling grid in France. Networks are running under the campus roads to connect its buildings, allowing them to benefit from geothermal energy captured 700 meters deep. It also allows the exchange of heat and cold between buildings. This is what we call heat recovery.
Actually, so as it was said, the Paris-Saclay grid is the first 5GHC grid in France. It's based on the geothermal energy that supplies the tempered loop. And then the energy goes to some active substation where there are some heat pumps that will bring up or bring down the temperature to the right level to a cluster of buildings. So as Herman said before, in some 5GHC grids, you have one heat pump per building. Here in the Paris-Saclay site, it's one massive heat pump for a cluster of buildings. So it's quite different from what was, for instance, done in Herlin in the first 5GHC pilot site. Maybe before we go into more details on the solar aspect of Paris-Saclay, could Herman maybe present the grid in the Netherlands quite quickly, and then we'll go back to the solar aspects.
Yes, thank you, Mathilde. Well, actually, in the city of Brunssum, so in Heerlen, we were building this system on the mine water reservoir. But we also had this movement that we wanted to connect 5 times more buildings on the same source. So thinking further, we said, well, if we go on in this process and make this grid so smart and so self-supporting, then we don't need a mine water reservoir at all. So in this project D2Grids, we started the scheme in the city of Brunssum without a mine water reservoir. But what we did do is drill for an aquifer. And this aquifer is, like the mine water is at 700 meters subsurface, but the aquifer would be like 80 to 100 meters. So in the bottom, you see an extraction well and an injection well. And we have a substation. It's a basement I will show later, which is having those pumps and feeding and then taking the water from the well. From there, we go to a central plant. So now we don't have those heat pumps in the buildings. It's in a basement also. And this basement is serving a district, an area, a neighborhood of buildings. We have connected 3 complexes called the Egg at the Celsius and Sabelbergstraat. And you see those from this thermal energy plant, we bring warm water, like 40 degrees, but it's weather dependent. So it's very cold. We can go up to 50 degrees and have a return pipe there to that energy plant. And also have a cold water system feeding 15 degrees to those buildings and have a return of 25. All in this system, it's mostly dwellings there, so it's not very optimized for 5G. We should really love to have some, like a shopping mall or something, offices in there giving us more cooling. But we have some 200 dwellings now connected in this pilot.
Okay, thank you, Herman. Would Alastair and John present the Plymouth pilot site quickly also?
Yeah, sure. Hi, I'm John Selman, also Alastair from Plymouth City Council, which is in the southwest of England, a coastal city. Just like to introduce the pilot site, which is in 2 distinct clusters, which we hope will join together, designed to join together, but have different characteristics. Can I have the next slide, please? It seems to be skipping. So the pilot is in 2 clusters which have different heat network characteristics, but in both areas we are trying to use multi-vector approaches where we're combining renewable electricity generation with the deployment of heat pumps and heat networks. So the first cluster is the Guildhall cluster in the city centre. So lots of mixed use buildings, but quite challenging buildings, some historic buildings, but we're relying more heavily on air source heat pumps, large air source heat pumps across a number of different locations within the heat network. But the interesting point here is also the air source heat pumps are designed, or some of the air source heat pumps are designed to connect and work in water source as well, as we connect into the 5th generation lower temperature networks. And what you can hopefully see on this slide is a green line within the map on the right hand side, which is the private wire network which exists in this cluster. And so we've been trying to maximize the use of this private wire to reduce the reliance on the grid electricity and maximize the deployment of renewable electricity on that network. Could I have the next slide, please? And in the first phase of this work, we've been putting significant amount of solar on our buildings connected to this private wire, but we've also been using a very small combined heat and power unit, CHP unit, really to try to balance the system between summer peak generation of solar, but also winter heat demand. And there's quite a significant demand, new demand within that network from the air source heat pump that's been delivered. The private wire network we're looking to expand to basically join in new generation, additional solar generation, but also additional heat pump deployments as the network expands in the second phase. If we could go to the next slide, please. I'll just hand over to Alistair to talk about the phase 2 of the Guildhall and also what we've been doing on one of our buildings to connect in Mill Bay.
Yes, hi, thanks, John. That's, as you know, a lot of work goes behind the scenes, so it's easy to talk about it, but it's a lot of work. At the top right there, there's a 3D version of what John was showing you from a plan view with the Guildhall and the council house and combined courts. That's where the private network is, the electrical network, and we are already, as John showed, putting solar PV on the council house. But we want to also look at utilizing a car park, the top roof of a car park, which is underutilized in the city, to put more solar PV on top. And at the bottom left there, there's an example of somewhere else in the city where that's already been done. We want to do that very possibly as a solar carport type of installation, where in the future, if parking is needed in there because there's changed use in the city, they can still be utilized, but we'll still get the solar. And we will, the idea is to bring a line across, a cable across from that PV system to the private wire. And of course, what that helps, as John mentioned, is to just balance the loads that are in there. We have heat pumps going in. So having renewable on site would help decrease the amount of grid needed and give a bit of grid relief. But also it's cost saving for the council, because we will be reducing the amount of import needed, and electricity is getting expensive. But also if we put batteries, and there's some pictures of some Tesla power walls, there's 3 banks of 3 there at another part of the city. The idea is to put a battery system into the council house as well, and we can then save power when we've got excess solar, and in the evenings and when the sun's down, we can still use that power to use for, in particular, the heat pumps when heating is needed. Yes, the next slide as well, please. So this is another part where we are also installing of the city, where we're also installing a heat pump, air source heat pump, which has the ability to connect to water in future, and certainly the whole system to connect to the district heat network. There's a split system with the compressor compound on the lower floor and roof mounted evaporators up on the roof. And the whole roof of that, the left is an old photograph from Google, and then you use a drone shot that we took of the solar PV on the roof with the evaporators in the center of the building, just in front of the lift shaft there that you can see. And so again, this is helping decrease the amount of extra electricity that will now be needed because of the heat pump. In Plymouth or in the UK, there's perhaps, I don't know if it's a unique situation, but gas is cheaper than electricity. So when you put a heat pump in, your overall energy costs actually go up. So to put solar PV helps reduce that situation. Of course, gas is getting more expensive. There's some numbers there about there's 64 kilowatts of solar on the roof, and the air source heat pump is around 200 kilowatts. Thank you.
Thank you to you too for this quite wide explanation on your grid and on the solar solutions that you have started installing on the rooftops. Maybe Luca, you want to present your project to provide renewable electricity, solar electricity to the grid of Paris-Saclay, and present maybe why Séquence has decided to do that, and what is your company?
Okay. Yes, I will start with who we are. We are a French social housing company. We own nearly 100,000 dwellings in the Parisian region. So 3 years ago, we've acquired 3 units on the Paris-Saclay district to develop 3 different buildings, which are going to be heated by the district grid. So we're a client of the Paris-Saclay heating grid. And in the process of the acquisition, we committed to install solar panels on the roof of our buildings. So we've made a lot of feasibility studies for our solar panels, and those studies have shown that we can install 250 square meter of PV panels for a capacity of 59 kilowatts and a production of nearly 60 megawatt megawatt hour per year. So we've searched of solutions to use this electricity, and we noticed that we can, of course, use this electricity for our buildings, especially for the shared equipments. But we also noticed that our peak of consumption won't be the same of our peak of production. So we searched several ways to use that excess of production, and we had a lot of discussion with the Paris-Saclay district, because of our status of client, and we find that they could use that electricity. So we've discussed with them and find that the excess of electricity produced by the PV panels can be used by the grid for their need in electricity, for their pumps, etc. And we are now in discussion to sell our excess to the grid, and it will enable us to maximize the consumption of electricity, to give our tenants cheaper electricity for their shared equipments, and also a more stable financially electricity to the grid. And I guess that's it.
Thank you, Lucas. And maybe we can say that this first example of Séquence supplying electricity to the Paris-Saclay grid is a small pilot site, and that the Séquence, the Paris-Saclay grid owner is studying how to duplicate this project to other buildings and other customers who might produce the electricity for their heat pumps.
Exactly, because we are going to use approximately 25% of the electricity for our buildings and sell 75%. But for the needs of the grid, it won't be a lot. But yeah, it's at small scale, it won't be a lot. But if they can reproduce it on all the buildings in the district, it can be a lot.
Thank you very much, Lucas. Herman, would you like to present what is planned on the Herlin pilot site for PV production?
Yes, I'm back again. So this is giving an overview of this area in the city of Brunsum. Actually, we have those pilots all over the Netherlands, where we try to make districts free from natural gas. And Brunsum was also selected to be such a pilot. So when we started there, the idea was that we would connect some 1,000 dwellings and some shops and some public buildings to in this scheme. And actually, this pilot from D2Grids was a startup. So I already said we had about 200 dwellings within the red circle, where we started to build this grid. And but the idea was to further extend it in the coming years. Next slide, please. So what we did is, this is the idea that we have a basement subsoil, and this is a concrete basement prefabricated. And in this basement, we bring in a skid with all those installations. This is pumps and storage vessels, but also the heat pumps and the controls that we need and the heat exchangers. And from this subsoil sector installation, we would connect all the dwellings, which actually now in this pilot are all new build dwellings. So that's a bit easier for the low temperature system. Next slide, please. This is another picture of this idea. Actually, we are very happy with this kind of prefabricated working because we have very little disturbance in this neighborhood. Only need 1 or 2 days to bring in the installations, and then we can connect them and start connecting the buildings to it. Next slide, please. This is a picture of this sector basement in the city of Ransom, and just behind it you see the new build. This is care buildings for all the people which are connected to this basement. Okay, next slide. So this is another picture of the scheme. On the bottom left you see the hot and the cold well from the aquifer. Then it's going to a first basement which has the installations for the aquifer, its heat exchanger and pumps, and then from there it goes to the second basement where we have all this technology to feed the four pipe system to the different complexes of dwellings. Okay, next slide. And a picture of those buildings that we connected. Left above, you see those elder care apartments for elder people. Actually, they do have a very nice flat roof. So we were looking for that roof if we can bring solar panels on them. And then on the right, it's old mine worker buildings, but they were rebuilt in the same style. People are really happy there, and they all connected also to the 5G. And then left bottom, we have a complex of apartments which also are connected to the system. On the right down, you see one apartment that we also provided with heat pump and internally made it ready for 5G. So we call this one 5G ready because we don't have our pipes yet there, but this building is already internally done. And if we get a pipe over there, then we will connect it to our grid. So this is a picture of the energy consumption. It's it's what the aquifer is doing. And you can see, and then we took about 3,000 gigajoule of heat from the source, but only bringing back 224 gigajoule of cold. So that was one of our problems. Those sources must be in balance, not to deplete them, but also for the permits that we have. So we need to look, we needed to look in more heat generation to feed the source with heat. Next one. If we look and we did this feasibility study, if we look into the power that we need, then we see we have a total power needed of 700 kilowatts of heat and about 300 kilowatts of cold. And then if we go into the energy that's consumed by that, you find those figures, about 4,000 gigajoule of heat and only, and I can't see that one, but it's some, I think, 600 kilowatts of gigajoules of cold. Okay, next one. So this is a more detailed scheme, how we look into the future up to 2030, and then you see that those heat and cooling demands, if we don't change the system, connect more dwellings, then that will be more or less the same. But also, if we feed this by airborne heat pump for the summer to generate heat for the source, then still we can see, and in the bottom we have the comparison to a traditional natural gas boilers and a traditional cooling system, that we still will have a carbon reduction in the system, which is going up to about 70%. Okay, the next. So what we were studying was different options to bring the system in balance. So that could be photovoltaic thermal, combined photovoltaic thermal panels, and then we would need some 1,375 square meters. As you can see, it's nearly 3,700 gigajoules, so that will be enough heat. Second one was bringing heat pipes on these flat roofs of the Celsius dwellings, but only giving us 1,600 gigajoules. We also studied on the dry cooler, which also only will give us 1,000 gigajoules, but is much cheaper. We looked at an asphalt collector. So can you bring pipes in the street in front of the houses and take heat from the asphalt of the street? The first one is a combination of the solar panels with the heat pipes on different locations, and the last one, a combination of those PVT panels with the dry cooler. Actually, from the study, we had this combination of PVT and not really the dry cooler. I think it should be 1 and 2. There is some mistake in my sheet. So the heat pipes and the PVT panels, and additional, you have some benefits there. So there will be no noise. You can tune those heat pipes so the amount of energy is adjustable. It's a lower investment, and it will also provide electricity, which can be used in our energy substation. And there was an opportunity for additional funding. Okay, so far I think that's my story.
Thank you very much, Herman. So we saw that there are some different technical solutions that are chosen or at least studied by each of the different pilot sites. So you have some PVT that is studied by the Brunson part, Paris and Plymouth has better chosen PV panels, some with storage, some don't use storage. So a lot of different solutions. We saw also that the governance can change. For instance, in Paris-Saclay, the consumers are the producers of the electricity. For Brunson and Plymouth, it might better be the grid owner or grid operator. So different solutions that that are being studied inside the D2Grids project. So thank you all for sharing everything. Would you have a final word before we go to the Q&A? If Emilia tells us we have time, because I see the time running. So if any of the pilot site would like to add additional information that they want to share to the audience, otherwise I can let Emilia go on with the presentation.
Thank you. Well, you think maybe we all also have a little bit of time at the end, but so we looked at these individual case studies, which make me think a lot of what we call positive energy districts, that we see that term circulating a lot. But now, how do installing these solar panels on roofs how can that help the system as a whole? And we will see here up from Framtiden AB in Gothenburg. They plan on installing solar panel roofs on all their dwellings. So I would like to ask Nina Jacobson to please let us know a little bit more about this plan you have, and how will this help balance the grid for the Gothenburg network. And I just want to remind our audience that in Gothenburg, depending on how you calculate, 95 to 97% of the buildings in the city are already connected to the district heating and cooling network, of which we are already using a lot of residual heat from incineration, from sewage water. So you have a very advanced network, but you still see this possibility to improve it even more. So Nina, how do you have these plans and support the city become climate neutral by 2030?
Thank you, Emilia, and I will just give you a brief introduction to how we think about solar energy in a system where we already have a lot of district heating. So you can just give me the next slide, please. Framtiden Company Group is the City of Gothenburg's public housing company. And we got around 75,000 apartments in all districts in Gothenburg. And this means that 1/4 of the citizens in Gothenburg live in a rental flat owned by our company group. The situation today, around 80% of our energy use is district heating and 20% is electricity. And as you see in these figures, and as Emilia already said, almost all our properties are connected to the district heating system. And the electricity use is mainly used for lighting and ventilation and shared laundry facilities and so on. And we got around 10,000 kilowatts of installed PV today. And we got just adopted new solar energy plan for Framtiden that is really ambitious. And the purpose is to mainly to contribute to the overall goal of the city, having a net zero carbon footprint by 2030. And a high degree of local renewable production of electricity. But if you see to Framtiden, the goal is to reduce our own climate impact, of course, and to reduce the amount of purchased electricity. And the solar energy plan says that we should use all our roofs so that is suited for PV systems to a maximum by 2030. And the plan is therefore to steer towards electricity production that may momentarily exceed the property's electricity need, meaning that we will sell electricity during part of the year. And the plan includes both existing and new buildings. Next slide. And just some figures on the capacity that we are aiming for. And all this installation is calculated to be a good return of investment. And we think even more profitable than we've been calculating with the energy prices right now. And the next slide. At the same time, we got an energy plan for the city of Gothenburg, and here we also investigate more smart systems and how the properties is more integrated into the greater energy system. And we will look into solutions like the grid, energy storage, positive energy districts. We have one pilot right now going on, etc. So installing PV systems is just a part of a more integrated system approach that we will continue to work on further on.
Thank you for that presentation and really forward-looking project you have for the city or for your buildings in the city. What I would like to once again ask our participants, feel free to use the Q&A session, but while people think and sort of digest your presentation, what do you see as the return on an investment period for these installations?
Right now, it's just in a few years, so less than 5 years with the current energy situation.
Excellent. And I think what I found very interesting from what you're doing at Framtiden is oftentimes when talking with cities and energy providers across Europe, they think, oh, it's the energy provider that needs to do the work and install these sessions. And here you see, no, the building owners also have a very proactive role to play in balancing the grid, in helping the city become climate neutral. One more question to you, Nina. If you see if people in the audience are looking to do this, what gave you the inspiration it's a very ambitious project to say, okay, now we will do this and it's a proper commitment. Where does that commitment come from?
First of all, we have this really ambitious environmental and climate program in Gothenburg that is decided by the politicians. So that is one part. But also we have, during the past 5 years, we had a plan for PV system installation as well. And this turned out to be a great success, and it's really profitable for us. So it's not just saving the climate, it's also a good business. So the lesson learned, we said, okay, then we can go all in up until 2030.
Yeah. And it's interesting because you have a major investment for very long term. How do you pick the right technology to do this? A big investment that needs to last 20, 30, maybe more. But we don't know what the system's in Gothenburg is going to look like then. So how do you plan for that balancing of an unknown future?
Right now, it's quite easy because the short time, the return of the investment is just a few years. That's not a big deal if we have to change the technology in upcoming years. But also right now we choose the really robust technique. That means monocrystalline PV solar cells that we know works for a really long time, and so we use the really safe way right now.
Great. We have only a couple of minutes left, so I'd like to invite all of our speakers to turn on their cameras and maybe do one last round of building on what Mathilde was asking earlier. For our listeners today that are interested in installing 5th generation district heating and making the best use of energy being produced renewably, what would be a word of advice that you would have for them? Something to keep in mind or something to avoid? So, John, let's start by you.
Yeah, certainly starting with looking at the source of heat, looking at the waste sources of heat, trying to map those out, trying to match that with the demands for heating and cooling in a certain location. So I think that would be the key ingredients for a 5th generation. Certainly we've managed to identify through the project a good geothermal source that we're tapping into, as well as seawater. I hope that helps.
Thanks. Alistair, what do you have to add to that?
Yeah, I think I can add in terms of sort of lessons learned from our side of the actual practical installation of the heat pumps and the networks and the piping within the buildings themselves is just making sure that in our case we had a lot of delays due to asbestos in the building, which turned out to be worse than we thought, that had to be dealt with beforehand, that delayed the project. And also really just as far as solar PV goes, make sure that your structural surveys are done in advance to check that the building can take it. And finally on that, certainly in the UK, we have to always be sure that we can connect to the grid, whether the grid can actually handle those capacity. If you can get those factors sorted out in the beginning, it's a lot quicker to get those installed on site.
Great. Herman.
Yes, thank you. Yes, well, actually, if I look into this technology, I think it has a lot of benefits. It's much more efficient than I think that we did in the past. So somehow this could have this should have a good future. We were getting close to a business case already in the past, some 2-3 years ago, saying, okay, we get 20% short in the business case, but now. The world is moving and prices are very fluctuating and fossil prices are going up very quickly. So already now I think we can find very good business cases to start building this on a small scale. And finally, in future, if you look at the system, say it's so much better than what we did in the past. So I cannot imagine that this system would not get cheaper in the future. One of the things is the city is a very complex. We have many stakeholders. It's not like car industry what we are doing. Because I often said if it was more simple, then we would have solved this problem already 30 years ago. So what we are looking into also for the next step, and we are writing an application for that, is that we get good models which will show what will happen to that city. How will our city look like in 30 years? And it's not just energy, it's not just carbon, it's also fine dust, it's urban heat islands, it's noise in the city, it's your architectural view. And so that's one need. We know many components and we know how it works, but if you bring it all together in an integrated system and to see what happens there, that we don't have that kind of model. So that's what we want to work on next.
What do you think, Nina? Is this something that from Tirineby could bring forward in Gothenburg? And what would be your one word of advice to give to our audience today?
First of all, there's no conflict between district heating and PV systems. So just start installing PV system, and it's a really easy technology as well. So it's easy even in the when you use the technology. But also that we will have to look into the system integrated parts like storage and so on. That will be a main focus for us the upcoming years.
So thermal storage. And Mathilde, would you like to give last words to round up this great webinar that's lasted an hour and a half? And for me, it's felt like the time flew by. I can't believe it for 1 minute left. Would you like to give a final word?
Sure. Thank you, Emilia. Yeah, so we saw that it's really interesting to have a holistic approach on both the thermal and the electric grid, as we mentioned a lot during this webinar. But what I would like to add also, and it's linked to one question that we had in the chat that was asked to Herman, is also to have like a really global approach, integrating also energy efficiency at the building level and gathering the strategy for renewable energy, be it both thermal and electric, and also the strategy for reducing the needs for energy at the building level. So that's also, as Herman said, something that we would like to study in a future project. And as Herman said, you can progressively install 5G. So maybe it's quicker to first install your heat pumps and change your energy emitters, and then progressively work on improving the building insulation, for instance, reducing its needs for high temperature and making it even more adapted to low temperature, ultra low temperature grid as 5G. and also thinking of adding the PV panels on the rooftop of each building. So it's really an integrated approach that should be brought by the municipality together with the customers, together with the grid owner, the grid operator, to have really a complete approach of the energy consumption and the energy production on all level and all type of energy.
Great. Thank you very much to the speakers for taking the time and sharing your knowledge, your experience, to the audience for listening to us and for your very interesting questions. I invite you all to go, if you want more information, check out the Interreg D2Grids website or the Celsius website, and we look forward to connecting and chatting with you in the future. Thank you.
Thank you. Bye.
Thank you. Bye-bye.